Welcome to the Lighthouse video series, where we dig into the technologies that Nichols Portland Inc. offers to our customers and support our customers in taking those technologies and using them to their fullest potential. I'm Stephen Medill. I am the Executive Vice President of Sales and Marketing for Nichols Portland Inc. Today I have with me Jason Osborne, VP of Advanced Engineering, and David Smith, our Director of Engineering for our MIM technology. We are coming to you today from our Center of Excellence at our Alpha Precision Group facility in Ridgeway, Pennsylvania. In this facility, we focus on the metal injection molding technology and our 3D printing or additive manufacturing. So gentlemen, thank you for joining me today. Today we're going to talk about tooling. Obviously, there's a lot that we could review in tooling, but what are the considerations that we consider for tooling?
So basically, we break our tooling approach down into three main categories. And during the requirements reviews, we vet out the requirements of the project, volume, annual usage that the customer plans on using, and then ultimately budget and cost, time to market. All of those things come into play.
Right.
So the first thing. The first approach we can take is what we consider either prototype or ultra low volume application. And so in a method like that, we would typically incorporate a single cavity tooling set. It would typically have hand load side action rather than fully automated side action. And a number of other things that we can employ to keep the cost down and speed up the time for tool build. The second option would be what we would consider a mid-range volume. So we would still use a lot of the same methods that we would take in the prototype, but potentially use a different type of tool steel. Potentially go from manual insert molding to automatic side action. And then the third would be high volume serial production. And in cases like that, we would use multi-cavity tooling, automatic slides, high grade tool steel, things like that. And that tooling is built for efficiency and longevity.
Yeah, high speed production.
Absolutely.
Yeah. So Dave, when we have these tooling considerations, what are kind of the pros and cons that we consider when we're doing that?
Yeah, sure. So the prototyping and severely low volume option, it's all about speed to market.
Right.
And it's vetting out a design and working through the development. We can iterate that very quickly,
Right.
At a relatively low cost. So that's a huge advantage to a customer who might not have a design fully vetted or wants initial samples to start working through endurance testing or any additional testing that they want to accomplish on their end.
Right.
So that's the huge pro. The con is it might not be the highest quality of component that you're receiving from this, depending on the tool steels that we're using and how quickly we're producing that that prototype or low volume tool. The mid range. Gives you kind of that middle of the road as far as tooling cost and lead time goes, right? So it will support production. However, in some cases, it might not support full-blown serial production at excessive annual usage, right? So again, this is where the information from the customer up front really dictates which direction we want to go.
Right.
The final option, that's going to give you the highest quality part with the most efficient process on our end.
Right.
Because that's going to be a fully automatic mold that has a reduced molding cycle time for us, produces high quality components.
Right.
That's the Cadillac of the injection molding industry.
Right.
And a lot of times, in polymer injection molding, they lean that way to support the volumes.
Right.
If the MIM volume is there to support it, you can go with that standalone and high volume production approach.
Yeah. And we have our own proprietary kind of tool design that we aren't going to share today, but I guess what question I would have is what are a typical lead time for those three different styles? Just typical. I know it's going to depend on project, but
Yeah.
just interesting to know what that gradient level is.
Yeah, sure. You know, the prototype and low volume tools we can have built in as little as a week. You know, so that's really getting the parts into the customer hands very, very quickly.
Right. Which is a huge advantage today.
Absolutely. That mid-range approach is, again, it's right in the middle of what you would expect a full-blown serial production mold, which is going to be in the 10 to 12 week time frame.
Right.
So that mid-range approach, you're typically looking at 4 to 6 weeks.
Yeah.
Which is relative to the industry, it's still really quick.
Right.
Especially the polymer injection molding industry.
Right.
However, you know, it isn't necessarily the serial production route, fully automated, high volume,
Right.
intent.
Yeah.
Yeah,
And then the high volume production would be in the
that's in the 10 to 12 to 14 week
Right.
range. Yeah, because you're talking multi cavities,
right.
and just overall increased complexity.
Yeah.
Yeah.
Well, it's definitely an advantage we talk about internally, and for our customers, we think they really today time to market's everything, and so the faster we can get our customers their product, it's better. So we are definitely proud of the system we've developed here. So thank you for the insight.
Yep.
If you guys have a project or would like an educational event that we could come on site to share with you, we'd love to have that opportunity. You can contact us either through the NicholsPortlandInc.com website or the AlphaPrecisionPM.com website, and we'll get back in touch with you. And we look forward to hearing from you soon.